Recording. So when I say prove it, for every object in a forces problem, you got to start with a free body diagram. You don't have to make it all color-coded. If you're a super crazy visual learner, it may be helpful for you. Some people like that. Some people don't care. And it's, entirely up to you. For any object, no, let's not do that. Let's do that. There we go. For any object with multiple forces on it, we can prove what any of those forces are. And one person today said it's easier when there are more forces. So let's start with the simplest permutation here. That object. Always start with the sum of forces. Now, in this case, we're not told that there are any forces on the x-axis. It's not a terrible habit to get into to go, okay, sum of forces on the x-axis is 0. No forces exist. This is proof. This is mathematically proving things. This is making notes about what is true that you can reference back to and say, because this is true, therefore this is true. And that's what a lot of math really is. So sum of forces on the y-axis equals all the forces up minus all the forces down. It's not a bad place to start every single problem. In a lot of problems, you will have multiple forces up, multiple forces down. So what if we decide, and I'm going to get rid of this, to really grossly complicate this, because we can, and do something insane like that? Well, this is where I tend to do, and I was mentioning the other, I tend to do those as like little dashed lines because it reminds me that this is just the, these are not the original forces acting on the object. This is the resolution of that force, which is a vector. And I can do the same thing over here. And I'm going to label each and every one of these. And I didn't give you names or anything here, so I'm just going to call this force A, force B, force C, and force D. And I didn't tell you if this is something that we're looking at from the top, and it's north, south, east, and west. I didn't tell you if this is something we're looking at from the side, and that's gravity, normal force, and forces right and left. I didn't tell you any of that, and frankly, right here, we don't really need that. We can get through this without that information. Now, to make a logical, reasonable answer that means something in the world, of course, we're going to have to know some of that. But, right at this moment, we can just do the thing that most of you are pretty accustomed to doing and say, well, this is positive y, this is negative y, this is negative x, this is positive x. And, that's sufficient. That stands in as a reasonable proxy for whatever other directions there are. Don't put directions in where they don't exist. If we're talking about something we're looking down on a map, and you say up, that makes no sense. Because it's not moving up and down. It's moving north, south, east, and west. Okay. I tend, and it's not a bad habit, on here I would label, here is my force B on the y, here is my force B on the x. Take as much paper as you need. Here is force D on the y, here is force D on the x. Use a whole sheet of paper for your free body diagram if you need to. Make that picture comprehensible. People are drawing pictures that are literally this big. It's like this. Go ahead, try to use that. Try to see angles. Try to see relationships. I dare you. Don't be afraid to use paper. I'll give you paper. I'll give you paper, sweetheart. You need more paper? I give you paper. I got paper. I got lots of paper. Don't worry about it. Do it on this area. It's just electrons. There's no paper involved. When I do this problem, if I'm looking at the y-axis, that's a y, that's a y, that's a y. I got 3 forces on my y-axis. And if my picture is big enough and useful enough, I can actually go through and I can put little checks or little codes to myself, or circle or square or triangle or whatever, color code, so that I don't miss a force on my y-axis. That's going to become really important when we start doing frictional forces and normal force, because there's one trap that people fall into, which involves forgetting a force. Don't forget forces. Terrible things happen when you forget forces. So I'm going to go ahead and say, okay, well, and if you need to do an extra step and list all your forces up, well, let's see, forces up. I got force A, I got force B on the Y, and of course I wouldn't want to forget force D on the Y, but that's down. Oh, wait, no, that's down. Jeez Louise, Moser. Get it together. Okay, so that's up, no other forces up. Okay. And then my forces down, well, I've got F sub C and I've got F dy. Okay. So at that point, I can actually say sum of forces on the Y equals, and I usually do this for myself, FA plus FBY minus FC minus FTY. I'll do that list, and then I'm able to reference my picture. I don't usually do this step. That's one that I kind of just did as part of the conversation we're having. I don't usually do that step. But I absolutely do that, because that gives me a reference to go back to, which is really handy for lots of things. Okay. So I also occasionally will make a list. I don't have an angle here. I don't have an angle there. In a real problem, of course, I would have to. But I can tell that FBY is going to be sine of theta, and FDY is going to be sine of theta. So sum of forces on the Y equals FA plus, and that's up, FB sine theta minus FC minus FD sine theta. And I put those stupid little arrows in because when I don't, I get predictable results. There. And then I would plug my values in, and then I would actually get a sum of forces on the Y. I would have a number. But I would have done all of that first. All of that listing, all of that bookkeeping. Remember when we did non-perpendicular vectors and I said this isn't hard math, it's just a pain in the tuchus. It's tedious, awful bookkeeping. That's what this is. You are bookkeeping all those forces. It gets more and more important the more we go, because the more forces we're going to add on the more angles. Okay. Questions on these kind of problems. And the thing is keeping track of all the moving pieces and making that picture big enough to be useful. Now, with headings, this is the last piece we'll talk about with this. So I've got this overall free body diagram, and it's pretty messy and pretty ugly. Whatever, and I don't even have real numbers in here, so whatever this is, let's say that this, well, I guess we're done. So, we'll talk more about it on Monday.